Hi guys, my name is Michael Randall, and I'm making this video today to review functional groups. I am a student at Whitworth University currently. I'm a senior. I'll be graduating this spring, going on to get my master's in teaching. And I'm doing these videos just to kind of help prepare me for that, as well as I currently am the supplemental instruction leader for Chemistry 102, and right now it's introductory bioorganic chemistry, and this is just going to be to help the students review functional groups, because at first those can be things that are hard to memorize and be able to recognize right away. So this video is going to aim at just helping remember those. So first one I'll start out with is going to be our basic hydrocarbon functional groups. Hydrocarbon. It's supposed to be a B. My stylus doesn't always like to write on the screen here. I'm doing this on my Microsoft Surface tablet, so please forgive the bad handwriting, and I'm sure I'll get better as these videos go on. But when we're looking at our hydrocarbon functional groups, we have three classifications. Essentially, we have an alkane, alkene, and alkyne. Alkene, alkyne. So, when we're looking at these are only going to be made of carbon and hydrogen. In the alkane, is just going to be a carbon-carbon single bond with hydrogens as well, so CH3, CH3. An ethyl group is essentially our simplest alkane, just ethane. Ane. When you're naming these, you use the end ane, ene, and ine when you're naming the groups. An alkene is going to be a carbon-carbon double bond, again with our hydrogens on either side. That's supposed to be a 2. Because carbon likes to have 4 bonds, we always like it to be happy and have its 4 bonds, so that's why when you only have a single bond, it can have 3, a double bond, it can only have 2, and when you have your triple bond, each carbon can only have 1 hydrogen on either side of it. So these are our most basic organic functional groups, and when we're looking at these, when we're identifying them in a molecule, the only thing we really have to look at is going to be the alkynes and alkenes, because an alkane is the simplest, and it just basically shows the backbone of the molecule. So if we had to go through and label every alkane, that would get really tedious, and it's really unnecessary. So just label the alkenes and alkynes, and not the alkanes. So let's get into some of our more interesting functional groups. Let's start with, oh dear, that's really big. Let's get rid of that. Okay, forgot to change my pen size there, sorry. Let's look at the alcohol functional group. So an alcohol functional group is simply an OH group, or an oxygen bonded to a hydrogen, and then the rest of your molecule over here, whether it's a substituent off the middle of a parent chain, or it can be terminal, just as long as it's connected somewhere to your molecule, obviously. So an alcoholic group can also be known as a hydroxyl. Hydroxyl. The names are interchangeable. Often as you get into upper division chemistry, it's more commonly known as the hydroxyl, but both work and are interchangeable. So we can classify these alcohols into 3 groups. We can have a primary alcohol, we can have a secondary alcohol, or we can have a tertiary alcohol. And those are just denoted by a 1, 2, or 3, followed by a degree sign. And if I can find the right color here, I will fix that one. There. So, when determining whether it's primary, tertiary, or secondary, we don't look at the alcohol itself, but we want to look at this carbon here, the carbon it's directly connected to, and how many carbons this carbon is attached to. So for a primary, when we just at least have one carbon or another R group off of that carbon, it'll be primary. For a secondary, we will have two. So that if we have two carbons coming off of the carbon right off of our hydroxyl group, it will be secondary. And for a primary, as you can probably guess, we will have three carbons or three R groups coming off of that carbon directly connected to the alcohol. So that's just a further way that we can specifically identify what kind of functional group we have on a molecule. So let me get rid of these so we can move on to our next functional group, which I think will be amines. So we're going to look at, let me change my pen size. There we go. So we're going to look at the amine functional groups. Needs an E. There we go. Amine. So an amine group is you have a nitrogen. It's connected to your R group or the rest of your molecule, and then off of its other two bonds, we can have either a hydrogen or an R group. And the R groups don't have to be the same. You can put an R prime there to denote that. And typically it is going to have a lone pair, because that's how nitrogen likes to have only three bonds and a lone pair, typically. If we look at its valence electrons and the theory there. So amines can also be classified as primary, tertiary, and secondary. Or primary, secondary, and tertiary. I guess I should go in order. That would help. Okay. So again, with just as like in the alcohol, it depends on how many groups are attached, but in the case of the amine, it's how many groups are directly attached to the nitrogen. So we're looking at the nitrogen. If it's just a nitrogen with two hydrogens and no R groups, then we're going to have a primary amine. So that's, that'll be a primary amine. If we go back here, and we have an R group and a hydrogen, then that means, since we have an R here, and a hydrogen here, that's going to be a secondary amine because it has two R groups, because we aren't counting the hydrogens. I'm sure, as you can probably guess, where we're going here, if we have no hydrogens, three R groups, it is a tertiary amine. And that's about as far as we'll get to in this class. When we get into charges, we can give the amine a positive charge, or the nitrogen a positive charge, stick on another group, and get a quaternary amine, which would have four R groups. But typically, in the introductory classes, we aren't going to see anything like that. So let's get rid of these again. Alright. So next, I want to take a look at the functional group known as the ester. Or ether, ether. I apologize. Ether. And what an ether is we have an oxygen in the middle, and it's a sandwich. We have an R and another R over here, whether that's R prime or the same R. It doesn't matter as long as it's two hydrocarbon groups on either side of an oxygen. You can think of it kind of like an Oreo, as Dr. Gard often says. The oxygen is your cream filling, and either R group is the cookie on either side. So we can call that an Oreo if that helps you kind of remember what an ether is. So that's really all that's really to ethers. Is just an oxygen sandwich between two R groups. So we'll move on. Second to erase that. Alright. Next in line, let's look at a thiol. And what a thiol is, it's just a sulfur hydrogen, or a sulfhydryl group, you could call it. Sulfhydryl group. So essentially, similar to an alcohol, it's just connected either on the end of a carbon chain, the end of a molecule, a terminal we call that, or it could be a substituent off of the middle. And thiols are not super common in organic chemistry, or typically what you will see in class. But it's good to know that they do exist, and they are there. So next, let's get into some of the more fancy groups. So let's start off with our base one, which I guess before I draw it, I should write the name. It's a ketone. Ketone. And what a ketone is just a carbon double bonded to an oxygen, and coming off of that, we have our R groups. I'll put R prime over there, and R over there. So again, they can be the same, or they can be different, and we'll see that ketones are a part of a lot of other functional groups, as you'll see, which is where the lines can become blurred, and it's easy to get confused. You see a ketone, it's like, they're often really noticeable, but you have to look at what's directly next to it in order to be able to properly classify it. So in here, to be able to label something as a simple ketone, it has to have the two R groups on either side of the carbon that's double bonded to our oxygen. And we'll see elaboration on this here in just a second as I get into these other functional groups. So let's look at a group of them here. We're going to look at an aldehyde. Oh dear. Alright. There we go. Aldehyde. We're going to have a ester. Which colors? A carboxylic acid. Carboxylic acid. I apologize for the handwriting. If I take my time and make it look nice, you'd be sitting here watching me with awkward silence for quite a while. So I get it so that you can tell what I'm writing, and I'm saying it at the same time, so hopefully that will help as well. Let's see, aldehyde, ester, carboxylic acid, and also an amide. And you'll see why I'm grouping all of these together in just a second here. So when we have an aldehyde, we're going to have an R group connected to a carbon, which is double bonded to an oxygen. Does that look familiar? Yeah, that's our ketone we just went over. But instead of another R group over here, we're just going to have a lone hydrogen. So this shows why it is important to look not only at our ketone group, but what is next to it. Because if we classify this as a ketone, we would be correct if we were only looking at the carbon double bonded to the oxygen in the middle. If we kind of narrow our view field just to that. But when we look at the area around it as a whole, it would be much more proper to classify this as an aldehyde. So an ester is going to be similar. We have our R group over here, carbon double bonded to our oxygen, our ketone, and then over here we're going to have another oxygen connected to an R or R prime group. Let me complete that circle there. Okay. So again, here you see an ether here, which is what a functional group we went over earlier. There's our ether directly next to our ketone. We can't classify these by themselves because they are directly connected to each other, so altogether this becomes an ester. So carboxylic acid, we're going to see our R group to a carbon double bonded to an oxygen, and this is going to be connected to an alcohol group or a hydroxyl. So again, like I did with the ester, you can split this into two. I see two things, but they're right next to each other, so I can't classify them individually. I have to say this is a carboxylic acid because I have an alcohol next to the ketone. And again, with the amide, our R group, carbonyl or ketone. You'll sometimes hear them called as carbonyls, but for the introductory class purposes, we're going to label it as a ketone. And attached to this, we're going to have our amine group. So we're going to have a nitrogen to a hydrogen or an R group, and another hydrogen or R group. Put our lone pair there. Proper Lewis structure. I guess if I'm doing that, I should do it with all the oxygens as well. So these are a group of some of the more interesting functional groups, if you will, that all contain ketones connected to other things. So again, this is why it's really important to be careful when you're identifying functional groups in organic molecules, that you look not only at the group itself, but what's directly connected to it, to be sure you don't mislabel anything. So give me just a moment to erase this. So the problem with memorizing, or with remembering all of these, is that basically you just have to memorize them. And I will tell you from experience that the more you see them, the easier it becomes. So this is something where it is just going to take time to do. What I would suggest, what really helped me, is note cards. On one side, you put the name. On the other side, you put the structure, or the basic structure, so that it will help you identify the group itself. The second thing that I would do is I would go to Google or your textbook or your instructor, or me even, if you leave a comment below or email me, I could come up with some for you. Instructor. When you go to these places, look up organic molecules. So just look up a bunch of different structures for organic molecules and go through them and identify the functional groups that you can see. So use your note cards to kind of learn them, basically, and then go look for real examples of them, so that if you see a weird molecule, you can try and identify it. If you still can't figure it out, or you're not sure if you labeled it correctly, you can bring it to your instructor and get double checked, so that way you can get the practice of actually seeing them. Because I know it's easy to say, oh, an R group is any kind of carbon group, when that turns into a benzene ring or a propyl group, or and any hydrocarbon group, it can be more difficult to see at first. So just get lots of practice with it. Please, in the comments below, leave any feedback, any questions, or suggestions that you have. And I hope this video helped, and there will be more to come. Thank you very much.